students. In previous model we discussed about the matter and their types. Today we will discuss about the international system of unit. In international system of unit we have discussed about the measurement of the weight, mass and other things. In this module we discuss another terms, that is uncertainty in measurement also. First of all, what is international system of unit? International system of unit is used for the measurement of the terms mass and weight. There are 7 basic units of measurements are. First one is length. It is represented by L and it is measured in meter and the symbol are M. Next one is mass. Mass is represented by M. Kilogram is the SI unit of that mass and it is represented by kg. Next one is time. It is represented by small t, second and s. Next one is thermodynamic. Temperature, capital T, Kelvin and K is the symbol of that. Next one is electric current. It is represented by I, ampere and the symbol is A. Next one is luminous intensity, IV, candela and CD is that unit of that particular. And next is that amount. It is small m, mole and the symbol is M. These are the 7 basic unit of system. Next is mass and weight. What is mass? If we talk about the mass is the amount of substance present in a body. That means it is constant. It never be changed. When we take a mass of that particular object in a one place, this is also similar and to the another place. And its SI unit is kg. So we can define mass is the amount of substance, or we can say matter present in a body. It is constant because it not change when we move place to place. Its SI unit is kg. Next one is weight. What is weight? Weight is the force exerted by the gravity. Weight depend upon the gravity. So we can say weight change place to place. It is not weight is not constant and the SI unit of weight is Newton. So we can define weight the force exerted by gravity. It varies from place to place because gravity changes from place to place. The SI system of that weight is SI unit is Newton. It is a vector quantity because it depends upon the direction. Gravity take toward itself, it force toward the earth or the gravity. So it is a vector quantity, mass is a scalar quantity. That's next one is volume. What is volume? Volume is the capacity of an object. How much amount it can take. That is the volume. So we can define it. The capacity of an object. It is known as volume. The SI unit of volume is meter cube. We can use liter to measure the liquid, but it is not a SI unit. 1 liter contains 1000 ml. 1 meter cube contains 1000 liter. It means 1 meter cube in SI system it have only 1 meter cube, then it contains 1000 liter liquid in an object. Next one is density. What is density? Density is mass per unit volume. Mass upon volume. So according to this, we can say that density is directly proportional to mass and density is inversely proportional to volume. With increase the volume, density decreases. With increase the mass, density increases. So according to the statement of density, that is density defined as mass per unit volume, the SI unit of density is kg per meter cube. Next one is temperature. It is represented by capital T. Temperature measures the hotness and coldness of the body. How hot is the object and how cold it. So it is defined as it measures the hotness and coolness of an object. It have 3 different scales: degree Celsius, degree Fahrenheit and Kelvin. It have 3 different scales: degree Celsius, degree Fahrenheit and Kelvin. The relation between degree Celsius and degree Fahrenheit. Degree Fahrenheit equal to 9 by 5 into degree Celsius plus 32. Why we have taken the 32? Because the scale varies. Degree Celsius varies from 0 degree Celsius to 100 degree Celsius. Degree Fahrenheit varies from 32 degree Fahrenheit to 212 degree Fahrenheit, and for Kelvin 273.15 Kelvin to 373.15 Kelvin. So that is the reason that we can add 32 in it. And when we take the relation between Kelvin and degree Celsius, then Kelvin equal to 273 plus degree Celsius. Now the question arises, at what temperature degree Celsius and Fahrenheit are equal? Let degree Celsius equal to x, degree Fahrenheit also equal to x. So we know degree Fahrenheit equal to 9 by 5 degree Celsius plus 32. Substituting the value of degree Celsius and degree Fahrenheit in this equation. X equal to 9 by 5x plus 32. Rearranging it, or we can say 5 multiplied by x and 5 also multiplied to 32. When we get the equation 5x equal to 9x plus 160, and then rearrange them. 9x minus 5x equal to minus 160, 4x equal to minus 160, and x equal to minus 160 by 4, x equal to minus 40. Minus 40 is that temperature at which degree Celsius and degree Fahrenheit are equal. Next is uncertainty in measurement. We know that when we do any experiment, we have a true value, another one is the experimental value. When there is no difference between true value and experimental value, then we can say our experiment is correct, 100% correct, because we get the 100% correct value. But when there is some differences between the true value and the experimental value, then we can say there is a uncertainty in measurement. So the next one is uncertainty in measurement. Uncertainty in measurement have two terms we can use in this case. Already I discussed here that one is true value and another one is experimental value. But in case of small amounts, such as we have taken as a chemist, we take as a atom or molecule, they are in very less amount. How we can find their masses also having very less, and even a less amount of atoms or molecule, they are having a large number of atoms or molecules are present. So we can measure easily them. They are having a one uncertainty measurement. One term is scientific notation. Scientific notation. Scientific notation is the exponential form. Why we have used this scientific notation? Because sometimes we have a very large value which is time consuming. Then to make to write in an easy way, we use the scientific notation, and this is also known as exponential form. It is also known as exponential form. Exponential form, such as in the form of n into 10 raised to power small n, where n lies from 1.00 to 9.999 and so on. And small n may be positive, may be negative, or may be 0. It may be positive integer, negative integer, or maybe 0. According to that, we can write the simplest way of a very large value, such as in Avogadro's number. We know that n is Avogadro's number. In this case, what we can see, the value is 60220000000. This. To make this, to write in an easy way, we can use the scientific notation. Then Avogadro's number is equal to 6.022 into 10 raised to power 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and 23. We write in such a way. It is very less time consuming. So next one is any terms having 0.00023. To write in a scientific notation, the answer is, this is also written in such a way, 2.3 into 10 raised to power minus 4. 1, 2, 3, 4. When we move this decimal from left to right, the power is negative. When this decimals move from right to left, then power is positive. So how many digits we can move? Then according to that, the power becomes maybe positive or maybe negative. This is the scientific notation. Next one is significant figure. Figures. Significant figure. Significant figure is the another term which is having the, we can say there is a error in somewhere when we doing some work or we can doing some experiment. We have three students, A, B and C. When they are doing some work, some experiment, one having the value of experiment first value is 1.95, second value is 1.93, second have 2.05 and 1.99, and third one having 1.99 and 2.01. What we can see that no one have the equal value of all the experimental things, only these two except. So they are having some error, somewhere they are having an error. This is due to lack of our concentration in the work, or somewhere the concentration of the reactants we have taken in there, or somewhere we can not wash the apparatus accurately, so that having some error. and the true value for this experiment is 2. Suppose true value is 2. Then two terms in significant is there. One is precision and another one is accuracy. Precision and accuracy. What is precision and accuracy? Precision means the nearest about, closest to the true value. The true value, we can say the true value is 2. So this one, student C 1.99 and 2.01 having the closest to that 2. They are also precise to each other as well as accurate, approximately accurate. But in this case, they are precise to each other. They are nearest about to each other, but not accurate. And these two values are not precise as well as accurate. In case of precision, there is only the plus minus of 0.1 or 2. 0.01 or 0.02 plus minus. According to that, we can find the accurate value of that reagent or that experiment. This is the significant figure. How we can find the significant figure? How we can calculate the significant figure? There are so many rules to find out the significant figure. Rules of significant figure. First one, all non-zero are significant. That is 2, 1, 3. How many they are? 3. These numerical values 1, 2, 3, they are 3 in numeral value, so the significant figures are 3. 2, 5, 6, 4. How many they are? 4. 4 significant figure. Second one, 0 lies between 2 non-zero is significant. Zero lies between 2 non-zero is significant. Like 1.002. How many they are? 4 significant. 101. 4 significant figure. Sorry, 101,001 in this case. So these are the two rules. Next one is 0 proceeding. The non-zero is not a significant figure. 0 proceeding non-zero is not a significant figure. Zero proceeding non-zero. That means 0.0025. In this case, how many significant figures? There are 2 significant figures. There are only 2 significant figures. Why there are only 2? Because these 2 zero are only indicate the decimal point. They are not having including in the significant. Next one is 0 lies right side lies after the decimal point is significant. Such as 1.00. There are three significant figures. 5.000. There are five significant figures. If the zero lies right side without except there is no decimal point, such as if 0 is in right side of non-zero, then it does not include insignificant figure, such as 100. In this case, only one significant figure is there. One significant figure. Such case is written in a scientific notation, that is 1 into 10 raised to power 2. So it have only one significant figure. Next one is, if there is we can say there is a 0 at the right and end of the right side of that particular non-zero, and there is no decimal point, then we can write in such cases such figure in a scientific notation, then we can get the exact significant figure of that that figure of that numerical value. Next one is rounding of significant figure. Rounding of significant figure. How we can round off the significant figure? First of all, first rule is, if the last digit is more than 5, then we can add the 1 carry to the second last digit. If last digit is more than 5, then we add 1 carry to second last digit, such as 6.20256. Then when we round off it, then we get 6.026. We can neglect this 6, 1 carry is added to in this 5. In this 5 we can add 1 carry plus 1. Then 5 plus 1 becomes 6. Next one is second. If the last digit is less than 5, such as 6.023, then we can neglect it and its significant figure becomes 6.02. Third one is, if the last digit is 5 and the second last is even number, then we can neglect it and we can write as it is up to the second last. And if it it have the second last digit having an odd number, then we add the 1 carry. Such cases, having two cases are there. 2.545. In this case, what we can see, how we can round off it. In this case, 5 is neglected because the second last is even number. Then it's round off, we get the 2.54 significant figure. But in this, in the other cases, 2.535. Then we can add 1 carry to second last. Then it become 54. This is the significant figure. That's all from my side today's, and in next module we can discuss about the law of conservation and mole concept. Thank you.